Good morning, students. So today we are going to learn the next chapter, and that is earthquakes. Now, an earthquake is a sudden trembling or series of vibrations or shock waves in the Earth's crust which occur due to sudden disturbances produced by internal or tectonic forces. In other words, the shaking of the grounds caused by internal movements by tectonic forces is called an earthquake. Rocks do not bend very easily, neither do they break easily. The movement of the plates are responsible for great tension in the rock strata. So, earthquake waves are generated when huge rocks break in the crust after being distorted beyond their strength. So, everywhere over here you can see the rocks break due to excessive distortion on them. Here due to bending, here due to the fault, and here due to the vibration. Now there are a few important terms which you need to remember. They are seismic waves, now this kind of concentric circles which occur when an earthquake occurs is known as seismic waves. When the tremendous energy stored in the rocks are released as powerful vibrations and tremors or shock waves, they are known as seismic waves. The energy spreads out as concentric circle. So the earthquake has occurred over here and the energy is now spreading out in concentric circles. From the focus over here, that is where the earthquake has occurred, in all directions. The seismic focus is the originating point below the Earth's surface, which usually has a depth of about 60 kilometers. The epicenter is the point on the Earth which is vertically above the origin of the focus, or where the earthquake has occurred. Seismology is the scientific study of earthquakes and other vibrations, and they are all being recorded in a seismograph. So what is a seismograph? It is a very sensitive apparatus that records the various earth motions caused by an earthquake. And the seismograph records the motions on a seismogram. So here you can see how the earthquake waves are occurring. The maximum surface waves, which is found over here, which we are going to study in the later part of the lesson. So all these studies are being made by scientists and we call them seismologists. a number related to the total energy released by an earthquake is known as the magnitude of an earthquake. Now, what about predicting earthquakes? It is very, very difficult to predict earthquakes because we do not have such devices which can record each and every movement of the earth. Nevertheless, the scientists are trying to develop such equipment which can tell us or forecast an earthquake at least a few minutes before the occurring of an earthquake. But for that, we have to develop devices which are very, very sensitive. However, as far as predicting earthquakes are concerned, it has been found that animals begin to behave very oddly just preceding an earthquake. Burrowing animals, underground creatures like snakes come out of their hibernation. Aquatic creatures like ducks refuse to enter water, and sometimes it has been found that fishes jump out of water just before an earthquake. Now, how are we to measure an earthquake? Earthquake can be measured on two important scales which have been developed by an American seismologist, Richter, and another seismologist, his name is Mercalli. So the Richter scale was first developed, and this is how it was named, or this was how it was projected. Later on, Mercalli came out with another scale, and he also introduced how the intensity or the shaking of the ground can be recorded and how we can determine what will be the consequences of an earthquake. Now, the destructive power of an earthquake is known as the intensity of an earthquake. The intensity of an earthquake can be described as the damage caused to buildings, dams, settlements, and other structures which are reported by witness. The intensity of the vibration is highest near the epicenter. So where the vertical point is just above the focus is the place where the maximum damage is caused. That is just above the focus. And as one goes away from this epicenter, the amount of damage becomes less. Now, how are we to record the seismic wave data? In order to record the seismic wave data, seismologists depend on three types of waves. They are primary waves, secondary waves, and surface waves or L waves. Now, primary waves are the fastest and they move whenever an earthquake occurs, and they can pass through liquids, solids as well as gases. Their velocity increases as they pass through the mantle. So we have the mantle over here, so their velocity gets increased. But their velocity decreases in the outer core because of excessive viscosity in the outer core. Their velocity decreases to a certain extent, and again it rises in the inner core. So this is how they travel, and we can see that they begin to get refracted as they pass through different types of structures inside the Earth's surface. Secondary waves travel through solids, and they cannot penetrate the dense molten core. That is the outer core, they are unable to penetrate. When these waves travel down the Earth, they meet the concentric layers inside, which keep them diverting from their original path. That means they also get refracted. So these waves bend and travel along a curved path. So these are the S waves. The surface waves or the L waves, they are the most dangerous because they travel along the surface, vibrating horizontally at right angles, just like sea waves, and they cause the maximum damage. Now, what are the causes of an earthquake? Earthquakes are experienced in areas of crustal instability, and they remind us of how the crust is so restless, and it is mainly due to tectonic forces. Volcanic activity is considered to be one of the most important causes of earthquake. During an explosion of a volcanic eruption, the gases try to escape upwards from the interior. Hence, they push the crustal area upwards, which cause an earthquake. Volcanic activities and seismic events are highly interrelated. A severe earthquake which was experienced at Mount Krakatoa led to the occurrence of tsunamis, and that killed large number of people in Java and Sumatra. Folding and faulting occur due to internal, horizontal and vertical movements, that is compression and tensional movements. Now this leads to the displacement of rocks to a great deal, and they disturb the crustal rocks and cause a lot of imbalance, and this can result in severe earthquakes. You can see over here how due to tensional forces the rocks are getting displaced. Here due to compressional forces the rocks are getting displaced again, and here due to horizontal movement of the earth the rocks are sliding against one another. The San Andreas Fault in California caused a devastating earthquake in 1906, which was experienced in San Francisco in USA. Now this is how the land looked like after the earthquake had occurred. Human beings are also responsible in causing earthquakes, which we call as anthropogenic or hydrostatic pressure earthquakes. These can cause due to dam building, construction of reservoirs, nuclear explosion, mining, drilling of oil, extraction of minerals. All these are responsible for earthquakes to occur, and they are all due to anthropogenic or man-made causes. In Maharashtra, the Koyna Dam caused a lot of devastation due to excessive storage of water and crustal imbalance which occurred because of the reservoir over there. Plate tectonics. Now, the plate tectonic theory describes that the crust of the earth is composed of a series of separate moving plates which move or slide over one another. There are several plates. All these black lines are the plates which are either sliding against one another, some plates are getting subducted, and all these can lead to causing of severe earthquakes. So they are all plates, that is, all the oceans and the continents are floating on plates. We can see the Indo-Australian plate, the Pacific plate, the Nazca plate, Antarctic plate, the South American and North American plates, and so on. The radioactive elements which are present in the Earth's crust and upper mantle give energy for convectional current. You can see the convectional current occurring. These currents slowly push the overlying plates here and there, and a great deal of displacement of rocks begin to take place along the plate margins. So a great deal of displacement of rocks begin to take place wherever two plates are found side by side. That's why the boundaries of these moving plates are associated with earthquakes, volcanic activities, crustal faulting, subduction of the crust, and so on. So all these areas, wherever we find the two plates coming very close contact with one another, we find volcanic activities, crustal faulting, subduction of the crust. Here we can see the ring of fire or the circum-Pacific belt, which is prone to active volcanoes and tectonic earthquakes. So all these areas near Japan, parts of Philippines, Java, Sumatra, they all undergo severe earthquakes very, very frequently. On the 26th of January 2001 at Bhuj, Gujarat, there was a severe earthquake, and it was due to the subduction of the Indian plate below the Asiatic plate. You can see the amount of disturbances and damage caused due to the subduction of the Indian plate along the Asiatic plate. It was here where Bhuj is, and here it caused this maximum damage. Now, effects of earthquakes can be very, very destructive. They can lead to loss of human life and animal life depending upon the destructive power of an earthquake, loss of man-made structures. That can also lead to large-scale killing and burying of human beings who can be caught unawares, devastating fires. Strong disturbances can lead to large-scale fires. It can lead to many people getting burned because of bursting of gas cylinders, destruction of oil refineries. All these can cause devastating fires that can lead to several people losing their lives. Landslides are also very common because of the shock waves and the tremors. Mountains begin to have a lot of disturbance. All the unconsolidated or loose rocks begin to slide down, burying villages after villages, and can cause large-scale destruction near the mountainous areas. Due to landslides, streams or rivers can be plugged, and that can cause the flash floods. Tsunamis can also occur because of the earthquakes, and these can result in large waves which can carry away thousands of people, animal, and can destroy the entire coastal area. Deformation of the ground can also occur, and cracks can develop at different areas. Cultivable lands may become unsuitable for cultivation ever again. However, there are certain constructive effects of earthquakes also. Due to earthquakes, the waves which generate tell us about the geology or the inside of the Earth's surface. Many minerals can be pushed up to the surface because of earthquakes. Fossil fuels become easier for us to access because the levels of where the fossil fuels are also made to come several meters closer to the surface. There are several other effects or constructive effects of earthquakes. They are the opening of fissures, and that can lead to the formation of geysers and hot springs, which provide us with medicinal values, and these geysers can also be harnessed for geothermal energy. So this is the diagram how the water of the geyser shoots up, and after the energy is released, they again fall down, and they are made to go down where the superheated water, due to the heat of the magma chamber, again leads them to be released into the air like a fountain. Elsewhere, we have found that coastlines get submerged due to earthquakes, forming bays and gulfs, which can help in better navigation. So this is the diagram which shows how this area after an earthquake got submerged. Now that led to this entire area to become a bigger water body through which navigation was made easier. As far as earthquake distribution is concerned, the entire ring of fire is associated with volcanoes and earthquake. They coincide with one another, and we have already learned what is the reason behind it. The Circum-Pacific Belt, or the Ring of Fire, is a region which causes a lot of crustal disturbances. Apart from the Ring of Fire, we have the mid-mountain belt. This mid-mountain belt stretches from Europe to Asia along with the Alpine mountain system, that is the Alps. This belt accounts for about 20% of the total earthquakes which occur in the world. The Mid-Atlantic Ridge. Now this belt includes the region of Mid-Atlantic Ridge, where two tectonic plates get apart. So these are the two tectonic belts and they are getting apart. These plates move in opposite direction. They are moving in, you can see over here, they are moving in opposite direction, and they help in spreading the sea floor. So the magma comes out, solidifies, pushes the older plate a few centimeters away, and this leads to the sea floor spreading. So moderate earthquakes also occur in this part of the region. About 10% of the total earthquakes of the world are associated with the submarine ridges, Rift Valley, etc. The map which is displayed on your screen shows the earthquake prone zones of India. So in India, the Himalayan region, this region is most prone to earthquakes. We call this region Zone 5 because it is highly prone to earthquakes. Along the foothills of Himalayas in the Indo-Gangetic plain, also some very devastating earthquakes have occurred. The Deccan Plateau is a comparatively stable landmass. So earthquakes with low intensity of this region has occurred, but there has been certain earthquakes which had been of very high intensity, like that of Koina, Bhuj, Latur, Jabalpur, etc. The rest of the areas are having earthquake, they fall in earthquake zones, but if ever earthquakes occur also, they will be of very low density. So you must go through this map which tells you about the 4 zones which are of different colors and will tell you which are the zones which are of high intensity areas of earthquakes and which are of low intensity of areas of earthquake. With that, we complete this chapter on earthquakes. I hope you have understood the topic well, and I assume that you must have enjoyed the topic as we maneuvered through the different diagrams as well as pictures which told us about how earthquakes can lead to so much of devastation and we can't do anything against nature. Thank you.